Good morning, class. You've got an experiment, which is an at-home lab for today's, or for this week's assignment. And I wanted to give you guys a little bit of a demonstration of what you're trying to achieve because the instructions were not incredibly easy to make sense of. So let's see if I can show a little bit of this so you guys know what you're up to. So I'm here in my baby's nursery where we change the diapers, and instead of two balls of different masses, I've got two canned goods. Maybe you can hear my 1-year-old crying back there. I've got two different masses of things here. I've got last Thanksgiving's pumpkin pie mix, 425 grams, and I've got refried beans, 879 grams, so about twice the mass. It asks you for two balls with different masses, but this works for me. You can see my socks in there. What the experiment is asking you to do is find two objects that'll roll and a ruler. I've got a nice metal ruler here I stole from my dad many years back. He doesn't know I have it. Probably he's forgotten about it. But I'm going to bend this ruler and try and do two different things. I want to put constant force on the two of these and see how the different masses are affected by a constant force. And then I want to try and produce the same acceleration. To do so, I'm probably going to have to use different forces. Let me see how I can get this set up so that way you guys can see. All right, so I've got them set up over here. For the first demonstration, you're taking your ruler and you want to bend it back the same amount for each of these. And if we bend it back the same amount, that means there's a constant force that this bent ruler is then going to release on these two things. So if I give both of these the same amount of force, and one is heavy and one is light, which one do you think will go further? Let's see. All right, so I'm going to put it up against here. I've got it bent a little bit. This is the heavier one. Not very far. I'm going to try and bend the same amount back. So which one went further? The heavier one or the lighter one? The lighter weight one, because for the same force, if you've got a big mass, less acceleration. If you've got a small mass for that same force, more acceleration. Now what we're going to try and do for the next part is get them to both accelerate exactly the same. If they accelerate exactly the same, that means I'm probably going to need to use either more or less force on one of these. So if I use more force on this big one, let's see how far it goes. So I'm going to bend it back a little further. Now if I want this lighter weight can to go about the same distance, am I going to need to use less force or more force? Probably a little bit less force, so I don't need to hold it back as far. Probably could have used a little bit more. You'll work with this at home. If you can get them going the same distance, that means they had about the same acceleration. And you can compare the difference of force required based on the different masses to get them to go with that same acceleration and therefore the same distance. So what you should be noticing is that you need a bigger force to send the heavier one all the way across. Let's see what it takes to get it all the way across there. So I'm going to do a pretty big force. Go! Go sideways. What if I do, I don't need as much force. Can I get it to go all the way across? Not quite. There's some trial and error. That's what you do in science. So that's what you're trying to do on part B of the experiment. That's my oldest daughter clapping over there. All right, thank you guys. Good luck. Let me know what you need.